Hello there, you are welcome. I am Uncle Agbaje. This is a video series that I'm doing on the Lagos State Certified Lesson Plans of the Lagos State University of Basic Education Board, LASUBEB, purposely for mathematics teachers who teach primary 6 mathematics and who may have a challenge teaching topics as it is being planned out in the lesson plan. I'm just going to be running through some of the plans as itemized, explaining methods that you can use to achieve understanding in your learners. The topic for this week is estimation and approximation, and this week we're going to be looking at the methods that you have been using, why that method may not work, and what method you can adopt to help your children understand estimation and approximation better. So without wasting much time, let's get right into it. So let's say you want to round off 2,468 to the nearest 10. But what you normally tell your children to do is to identify the digit in the tens position, which is 6. Check if the digit after it is greater than 5 or 5. If it is greater than 5 or 5, then you add 1 to the tens place. But if it is less than 5, then you keep the tens place like that. Now what your children can do is that they write 2, 4, and then they notice that after 6 here there is 8. Since that is more than 5, they have to add 1 to 6, and that gives 7. And so in most cases, and that's a very common error, they end up by saying 2,468 is approximately equals to 247 to the nearest 10. But you and I know that is not the case. Besides, if you teach them this rule today, next week you have to teach them another concept and another rule, another concept and another rule, and they keep having to cram rules. And that is why sometimes you teach children at the beginning of the term and towards the midterm or towards the end of the term, they seem not to remember what you have taught them before because they always have to cram so many rules. How about you teach them in a way that makes more meaning to them? Let's look at the same problem in a different way. We have to round off 2,468 to the nearest 10. What does that mean? What are numbers in tens? When we count in tens, we're going to have 10, 20, 30, 40, all the way to 90, 100, 110, and so on and like that. When we count in tens, there will be no digit except 0 in the unit places. Okay, so when you have 2,468, there is supposed to be nothing in the unit place, only the tens place has to keep increasing 1 to 2 to 3 to 4, all the way to 9. So what that means is that you cannot have 68. It's supposed to end with either 60 or 70 or 80 or 90, and so on like that. So in counting in tens, you're going to have 2,450, 2,460, 2,470, 2,480, and now we're counting in tens. But this number that we are given, 2,468, is supposed to be in between one of these numbers. Is it between these two? No. 2,468 is going to be between these two numbers. So we're going to extract those. 2,460, 2,470. And these right here form what we call the upper bound for these numbers. Now 2,460 forms what you call the lower bound for the number. 2,470 is the upper bound. And so somewhere here we're supposed to have this number 2,468. So which one is it closer to when we're counting in tens? Is it closer to 2,460 or 2,470? Now when you explain like this, it begins to make sense to the children. 2,468 is closer to which one? They can determine that by themselves easily. But to help them determine, we can introduce the concept of the mid value. In between 60 and 70, you're going to have 65. So that means that in between 2,460 and 2,470, you're going to have 2,465. This right here is what we call the mid value. Now all you have to do is now determine if the number you're working with, 2,468, falls to the left or to the right. In this case, 2,468 is after 2,465, so it is somewhere here. 2,468. So as a number, the closest 10 to 2,468 is actually 2,470. It is farther away from 2,460. So this is the way that we have to go. So in essence, what are we trying to say? We are trying to say that the closest 10 to 2468 is actually 2470. This example says we should round off 6524 to the nearest 100. Now when we're counting in hundreds, we're going to have 100, we're going to have 200, 300, all the way to 900. And so we're going to have to find the lower bound. In this case, when we're counting in hundreds, we can't have 524, we can only have 500, and that's going to be our lower bound. So getting the lower bound is very easy. Since we are rounding to the nearest 100, we just pick the 100 digits and form that as the lower bound, 500. So we're going to have 6500, and then the upper bound will be 6600, the next 100 after 6500. So forming the lower bound and upper bound is very, very easy. Now the mid value is also important, because if we're going to be having trouble situating our number, then the mid value should really help us. Between 500 and 600, we have 550. That is the mid value. So if we have 6500, then it should be 6550. So this is the mid value, this is the lower bound, this is the upper bound. Okay, all these are just fancy names. You don't need to worry yourself too much. Question is, where does 6524 lie? 524 will be after 500, before 550. So it's going to be here. 6524 is going to be on the left here. So when we now compare the distances, we see that this is closer to this and is farther away from this. The nearest 100 is 6500. The farther 100 is 6600. So we say that 6524 is closer to 6500 to the nearest 100. And how do we write that? We write that does 6524 is approximately equal to, this is a mathematical symbol that means almost equal to 6500 to the nearest 100. That is that about that. Let's take a look at another example. This example says we should round off 2.815 to the nearest whole number. Now, as you know, the decimal point divides a number into two parts. The whole number part on the left, the fractional part on the right. So this is where the whole number is. And when we're counting in wholes, that is also counting in units. But you rarely find textbooks that tell you to round off to the nearest unit or to the nearest one. Just say round to the nearest whole number. So we're counting in wholes. We're going to start with 1, 2, 3, 4, all the way to 9, and then we continue on and on like that. So, but in this case, we have 2.815. With lower bound is going to be 2 units, because we have 2 in the unit position, lower bound, and then the upper bound is going to be 3 units. But because we have 3 decimal places, we can write this as 2.000. This is going to be 3.000, just to make sense. Now the middle value, since we have 2.0, 3.0, the middle value of course is going to be 2 and then a 5 after it. So that's going to be 2.5. We can put 2 zeros to maintain our 2 decimal places. This is the middle value. Now where will 2.815 fall in? We can just think of this as 2,815. It's going to be 2,000 after 2,500. Well, whichever case, it's going to be on this side, 2.815. And so this is where our number is situated. So the units that we are considering, lower bound is 2, upper bound is 3. Which one is it closer to? It is closer to the upper bound. So we say that 2.815 is closer to 3.000, or you can just cancel the 3 zeros. Trading zeros after a decimal number is irrelevant. It is 3 to the nearest whole number, and that is all there is to that. So we have come to the end of this presentation on estimation and approximation. In fact, what we have done today is just approximation. In subsequent lessons, we're going to be looking at estimation, significant digits, and also some other rules that apply to estimation and approximation. See you then. Bye bye now.